Unlike ionic compounds or metallic compounds, covalent compounds exist as individual molecules, right? And these molecules are held together by intermolecular forces. We can talk about intermolecular forces in a bit. Okay, these intermolecular forces are not the result of attraction between opposite charges, like in metallic compound or ionic compounds, like cation and anion. It's result from polarity. Now let's take a look. So, molecule of water. If you remember about electronegativity, so the electron within this bond will spend more time on oxygen, so it kind of go toward oxygen, make oxygen slightly negative, not a real charge, not a real negative, just slightly negative. We use the delta sign to show there's a partial charge, okay, a fraction of the charge. So we have partial negative charge and partial positive charge. The other molecule of water, so we have partial negative, partial positive. The negative and positive, they attracts, right? They attract each other, and that is the intermolecular interaction, so between the molecules, all right? What we call intermolecular interactions. I'm going to show you, don't get confused with the ionic bond, covalent bond, or metallic bond. I'll show you in a bit. So this is between molecules. The intermolecular interactions are usually, actually, though, are much weaker than the interaction of ionic compounds or metallic compounds. In an ionic compound, if you remember, let's say sodium chloride. So chloride is negative 1. Sodium positive 1. The charge right here is a real charge, right? But the charge in it's not even a charge. In a covalent compound, it's just partial charge. So the Q is less than the Q right here. This Q is big in ionic compound or a metallic compound. In covalent compound, the two Qs are smaller. That makes the attraction weaker than those of ionic compound and metallic compound. And to show you it's really weaker, let's take a look at the boiling point. In an ionic compound or not covalent, metallic compound, the boiling point is like 1,000 degrees, right? In a covalent compound, it's only 100. 19.5 is low, much lower. Okay, all right. Which of the following are the characteristic of an ionic compound? 1, malleable. No, if you hit an ionic compound, it breaks, right? If let's say you hit right here, the whole lattice move downward, the negative and negative going to be, you face each other, positive will face each other, and then repel. So that's the, so it's not malleable, right? Only metallic compound, yes, malleable. High boiling point, yes. Low melting point, no, that's a covalent compound, low melting point. Electrical conductivity, yes or no? I'm going to say no, right? By itself, it cannot conduct electricity. If you want it to be able to conduct electricity, you can do 2 ways. 1, melt it. So positive and negative can move around, right? Positive ion and negative ion can move around, and they can conduct electricity. Or put this into water. If it dissolved, the cation and anion will be free, and then it can move, right? So anything that can conduct electricity, the cation and anion have to be able to move. Okay. Intermolecular forces. No, we talked about earlier. That's a covalent compound. Lattice, yes, of course. Okay. All right. Class activity number 1. Shouldn't be difficult in here. All right. Let's moving on.